Assalamu alaikum. We will continue Chapter 9, Straight Lines, Part 2. Objectives. Study the relative position of two straight lines. Determine a Cartesian equation of a line D passing through a given point and parallel to a given line. Find the coordinates of point of intersection of two straight lines by calculation. Please prepare the following materials: textbook, pens, draft papers, copybook, and calculator. Relative position of two straight lines. We will speak about parallel lines in this part. Given the two straight lines D1 and D2 written in their Cartesian form, and the two vectors U1 and U2, the directing vectors of D1 and D2 respectively, as you can see in the figure here. Property. D1 and D2 are parallel if and only if U1 and U2 are collinear vectors. Remark. In case where D1 and D2 are written in reduced Cartesian equation, then D1 and D2 are parallel if and only if D1 and D2 have the same slope. Example. Number 1. Show that the line D, 2x minus 5y minus 8 is equal to 0, and the line M, 4x minus 10y plus 11 is equal to 0 are parallel lines. Number 2. Show that the line D, y equals to x minus 1, and the line M, y equals to x plus 3 are parallel. Solution. As for part 1, let us find the directing vectors of D and M, since D and M are written in their Cartesian form. The two directing vectors U, 5, 2, and V, 10, 4 are collinear vectors. Since 5 over 10, it is equal to 2 over 4, it is equal to 0.5. Then D and M are parallel. As for part 2, let us find the slopes of the lines D and M, since the lines D and M are written in reduced Cartesian form. The slope of line D is equal to the slope of line M, it is equal to 2. Then D and M are parallel lines since they have the same slope. We will see in this part how can we find the equation of a line passing through a given point and parallel to a given line. Given a straight line D and a point A that does not belong to line D, and the vector U minus BA is a directing vector of line D. Property. The Cartesian equation of the straight line M that is passing through point A and parallel to line D is given by x of vector U over x minus xa, it is equal to y of vector U over y minus ya, where M, xy is a variable point on line M different from A. Example. Given the line D, x minus 2y minus 1 is equal to 0, and the point A, 1, 2. 1. Verify that the point A does not belong to line D. 2. Write a Cartesian equation of a straight line M passing through point A and parallel to line D. As for part 1, to verify that point A does not belong to line D, we substitute the coordinates of point A in the equation of line D and see if we will get 0. If we substitute the coordinates of point A in the equation of line D, we will get x of A minus 2y of A minus 1, which is equal to 1 minus 4 minus 1, it is equal to negative 4, which is different from 0. Then A does not belong to line D. As for part 2, to find the Cartesian equation of a straight line M passing through point A and parallel to line D, we find first the directing vector of line D. Let U, 2, 1 be the directing vector of line D, and let M, xy be a variable point on line M. Then, the line M is given by x of vector U over x minus xa, it is equal to y of vector U over y minus ya. We substitute each by its value, then we get 2 over x minus 1, it is equal 1 over y minus 2. And we continue to get x minus 1, it is equal to 2 into y minus 2. This means that x minus 1, it is equal to 2y minus 4. Then the equation of line M is x minus 2y plus 3 is equal to 0. Application. Given the two lines D, 2x minus 7 is equal to 0, and the line M, 6x minus y is equal to 0. Are the two lines D and M parallel? Justify. Part 2. Verify that the point A, 1, 2 does not belong to line D, neither to line M. Part 3. Write a Cartesian equation of line D1 passing through point A and parallel to D. Number 4. Write a Cartesian equation of line D2 passing through point A and parallel to line M. Pause the video and solve this application. Solution. As for part 1, to find if the two lines D and M are parallel, we find the directing vectors of the lines D and M and see if they are collinear vectors. Vector u 0, 2 and vector v 1, 6 are two directing vectors of the lines D and M respectively. 0 over 1, it is not equal to 2 over 6. Then the directing vectors u and v of the two lines D and M are not collinear vectors, then the lines D and M are not parallel. As to part 2, we substitute the coordinates of point A in the equation of line D first, so we get 2xa minus 7, it is equal to minus 7, which is equal to minus 5. It is not equal to 0, then A does not belong to line D. Also, we substitute the coordinates of point A in the equation of line M. So we get 6x of A minus ya, it is equal 6 minus 2, which is equal to 4, does not equal to 0, then point A does not belong to line M. As for part 3, let mxy be a variable point on line D1, different from A. Then the equation of line D1 is given by x of vector u over x minus xa, it is equal y of vector u over y minus ya. We continue and we get the equation of line D2, 2x minus 2 is equal to 0. We have another method to solve this part. Notice that the line D is parallel to y-axis. And since line D1 is parallel to line D, then line D1 is also parallel to y-axis. So the equation of line D1 is x equal to constant. But point A belongs to line D1, then we have the equation of line D1 is x equal to 1, which is the abscissa of point A. Part 4. Let mxy be a variable point on D2 different from A. Then the equation of line D2 is x of vector v over x minus xa, it is equal y of vector v over y minus ya. We continue and we get the equation of line D2, 6x minus y minus 4 is equal to 0.